In this video, I'll show how to build a conveyor belt using Godot. I was running into a problem when building levels for Kinetic Conundrum, which is a puzzle where your goal is to wrangle balls through a maze. The problem was having a mechanism to move target balls upwards from lower platforms. You'd either have to start with the target balls at the top of the level or build a series of ramps to push them up, which can be limiting and awkward for level designs. To solve this problem, I created a new element, a conveyor belt, that can work as an elevator or escalator depending on the angle you put it in. This solved the problem of moving the balls up, and as a bonus, gave me new ideas for puzzles. Let's look in more detail how this was built in Godot editor. Here we can see an example of a conveyor belt. There's a cog that's a straightforward rotating shape and a chain that's pulled by the cog. The chain is made of chain links. These are kind of T-shapes which allows them to push or lift other objects. The lifting part of the link body is slightly pointed, which gives them some slope so balls can roll off when the conveyor belt is used as an elevator. The trick is in how the chain links are connected. As a real-world analog, think of a bicycle chain where two links are connected by a pin that holds them together but also allows them to pivot. In Godot, you can implement this design by using RigidBody2D and PinJoint2D nodes. Each chain link consists of a link body and a pin, which are represented by rigid bodies. There's also two pin joints. The first one connects the body to the pin, and the second one connects the pin to the next link in the chain. Notice that the second link or the second pin is dangling. This is because we don't know yet what it's supposed to connect to. We only know that once we are in a process of building the entire chain. To handle this, I wrote a bit of code that takes care of linking the pin joint to the body of the next chain link in runtime. We also expose the next link as an exported variable, which made it easy to build different conveyor belt designs. So we can simply put the chain links in a chain configuration, and then connect each link to the next one. In object-oriented programming jargon, this is an example of encapsulation where the internal logic of how the linking happens is hidden from the higher levels. Let's also look at the cog. It's a simple hexagon because having a little bit of an angular shape helps to keep the chain from slipping. It has similar pin and pin joint design to allow it to rotate. However, in this case, the pin is a static body 2D to keep it in the same position. It's even forced to go back to its initial position during physics processing, in case the physics engine does something weird and moves it slightly. The cog can also be powered to rotate so it pulls the chain in a proper conveyor belt action. We can see two exported variables, the motor enabled and the motor target velocity. Let's see how this works in practice. Let's build a simple conveyor belt design. So first, let's instantiate a child scene, the conveyor example, and let's move this more towards the center so we can see it better. And let's also power this up. And now let's try running the scene. So we can see the motor is turning, but the chain is flopping around and it's not working very well. So let's fix this. We need to add another cog that can act as a guide wheel. We'll keep this cog unpowered so it can rotate freely. We can also build a kind of an elevator shaft around the belt. So this also helps to keep the chain from flopping around. And now let's try running the scene. We can see it's working much better. The chain is not flopping around, and the elevator is in a working order. So this is quite a flexible design. Like I mentioned, you can put the conveyor belt in different angles if you want to have an conveyor belt versus escalator versus elevator. You can add or remove chain links to change the length, or you can also add more guide wheels to create different designs. There's a couple of caveats. You shouldn't make the chain too long because it might start to sag and tense under its own weight and won't behave properly. You can mitigate this problem a bit by reducing the gravity effect on the links, but making the gravity too low in turn causes other problems like the chain floating around and slipping. Also, there's a bit of finessing into getting the length of the chain links versus the cog size just right, so that the chain rolls around the cog nicely and doesn't slip or get over or under tensioned. To save you the work, I made these Godot scenes available on my GitHub site, so you can check out some examples. The GitHub link is available below in the video description. To try out new kinetic conundrum puzzles with the conveyor belt designs, visit my project website at rastala-games.itch.io. Click the link below in the video description.